All right, so you just looked at the video on the front of doing long division. Sometimes we have a process that we can do that'll shorten or speed that up a little bit, kind of a shorthand way, which is something called synthetic division. Unfortunately, not every problem can be done with synthetic division, but the ones that can, you should. It's going to save you some space and some time. Okay? So how does the process work? Well, here's 5 steps. Step 1, write the coefficients on the polynomial from highest exponent to lowest. Put zeros in if the polynomial is missing a term. So we're talking in the divisors, the ones that go underneath the square, or taking the division sign. So the x coefficients are like the numbers in front, like 1, -3, 5. So I want to make sure that if this is starting at an x squared, it goes down from there, like x squared, x, constant. If there are anything that's missing, we're going to put a 0 in its place. Basically what synthetic division does is it allows us to do the operations without carrying all the x's, all of the variables. So we have to keep up with its place by putting placeholders and holding that spot. Okay? So set the divisor equal to 0 and solve. So this thing out here, we're just going to find a number. We want the x-intercept or the root. Like if I had set that equal to 0 and solved, if it was part of a quadratic, that would be where it crosses through the x-axis. That's what I want to know. I want to know the actual x-intercept or root. And then once you get it set up, it says you're going to bring the first term down. Got to have something to start with. And then it's just a pattern of multiplying and adding, multiplying and adding, multiplying and adding down until you get to the end. The last number remaining, in this case, that'll be your remainder. Okay? That'll also be, when they say the answer, that'll be the value. Like if you evaluated this polynomial at that x value, that's the number you would get, that last number. Okay, so let's look at some of these. So here's my divisor. Here's my divisor, sorry. I'm going to set that equal to 0. And so I would get x equals 1. Okay, that's the root. That's going on the outside. I'm going to make myself, kind of looks like a half a box. I'm going to leave a space. We're going to write on this row right above it. And then I'm going to write all the coefficients, the dividend underneath. So 1, -3, and 5. So that's the setup. And then you go ahead and you pull the first number down always. You need one number to work with. Once the number hits the bottom, it always gets multiplied to this intercept you wrote out here. So in this case, 1 times 1, and you write it in the next open spot. Okay. And then we always add down. So -3 plus 1 is -2. Once the number hits the bottom, multiply it to the outside number. So -2 times 1 is -2. Write it in the next open spot, and then add down. So we get 3. I usually kind of put a little box or a line to separate that out because that's your remainder. Okay, so this last number is always your remainder. Next one over will be your constant term. Then your x. If there was another one, be x squared, and then x cubed, and so on. It just keeps working its way up. So I've done the division. Now I just need to write it so it looks like the form. So the x is going to go back here. So my answer is going to be x minus 2. And this is a remainder, so plus 3 over my divisor, which was x minus 1. Okay, so that's my answer when I divide this quadratic by x minus 1. So if you did it with long division like we did previously, that would be the answer you get. Okay, we just got to shorten it up and not carry all those x's through the problem. Okay, it really saves time when you get problems like number 2, when they're to really high degrees, where you'd have to keep dragging that out and starting the process over and over again. So first thing I want to check is if I set this equal to 0, what number do I get? It'd be -6, so that's going on the outside. Okay, I want to go down my polynomial, starting at x to the 5th. It should go 4th, then 3rd, then squared. So I'm missing this x cubed term. So I'm going to have to put a 0 in that spot that would hold that value. So as I'm listing the coefficients, I'd have 1, 6. The cube term is missing, so I'll put a 0 to hold that spot. Then -3, -22, and -29. And yes, if the constant's missing, you need to put a 0 in that spot. It should start at the highest degree and all the way down to the constant. So if the highest degree is 5, you're going to end up with 6 terms. The highest degree was 2, you end up with 3 terms. All right, let's start the process. First one just comes straight down. Remember, when it hits the bottom, multiply it to the outside. So 1 times -6 is -6. So write that in the next spot. We always add down in synthetic division. So that column gives me 0. Multiply out. 0 times -6 is 0. Add down. So 0 plus 0 is still 0. 0 times -6 is still 0. Okay. I'm going to add down. So -3 plus 0 is -3. All right. So -3 times the -6 out here is going to give you an 18. And then add down. -22 plus 18 gives me -4. And one last multiplication. -4 times the -6 out here gives you a positive 24. And when you add down, you get -5. So our remainder is going to be -5. My constant will be -4. My x term is -3. My x squared term is 0. My x cubed term is 0. And my x to the 4th term is 1 for a coefficient. Now, we don't usually need to write all these zeros in here, so our final answer is just going to be x to the 4th minus 3x minus 4, and then your remainder is negative, so -5 over x plus 6. Okay. And again, it makes sense that we got an x to the 4th because we started with an x to the 5th, and we divided it by an x. So 5 minus 1 gives me x to the 4th. All right, number 3. Again, as I'm looking at number 3, I notice I start with a cube term, but I'm missing a squared term. So we need to be sure to fill in a 0 for the squared term. All right, so if you set that equal to 0, we're going to get that our x-intercept is positive 3. That goes on the outside. Got a 1 for a cube term, missing a square term, so hold the place with a 0. -3 and 1. Okay, that'll be my remainder out there. So bring the 1 straight down. 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. Add 9 to -3, you get 6. 6 times 3 is 18. So when I add that to the 1, I get a remainder of 19. All right, so put the x's back in. So constant x, x squared. So this one, when you divide, you get x squared plus 3x plus 6 plus the remainder of 19 over x minus 3. Okay, if you want to try the last one on your own, go ahead and hit pause at this point, try it, and then come back and see if you got the same answer as me. All right, so I got a -2 on the outside when I set this equal to 0. When I'm going down my list, I am not missing any terms, so I can just write all the coefficients. So 1, 10, 21, 6, and negative 8. Pull the first term down as 1. Multiply to negative 2. That adds to 8. 8 times negative 2 is negative 16. That adds to 5. 5 times negative 2 is negative 10. That adds to negative 4. Negative 4 times negative 2 is 8. And so that adds to 0, which means this time I get no remainder. So that x plus 2 goes in there an even number of times. If you put your x's back, it actually goes in there x cubed plus 8x squared plus 5x minus 4 times. Okay? Obviously, the division using synthetic division is much kind of quicker, neater, and easier. Unfortunately, not everything can be done with this. In order for you to use synthetic division, this has to be true. So write this down. In order to use synthetic division, the divisor must be in the form either x plus some number, so I'm just going to say k to stand for some number, or x minus some number. Okay, it can't have a squared in the x, can't have a coefficient in front of it. Has to be x plus a number, x minus a number. So if you look at all 4 of these, they're all like x minus 1, x plus 6, x plus 2, x minus 3. Okay, if you went back and looked at the one from the front page of the other video, you would be able to do number 3 using synthetic division, you get the same answer. But number 1 and number 2, those divisors are not in that form, so you would have to use synthetic division for those 2. Okay? If you're still looking for some additional help or work on that, there's some extra links here that you can view, take notes on if you need them. And then when you're ready, your homework, you've got the first 3 problems. If you'll notice, all these have to be done by long division. And then the last 4 problems, those all have divisors which will allow you to set up the synthetic division and solve them.